there anything there anyone would like me to explain, or did I screw something up? Yes, Tanveen. Did I screw that up? Here, let's take a look. Now I'm second guessing my multiplication tables. I hate 8. Here we go. 8 to... Oh, it'll still be 6 because 7 is 56. But it's going to be 6 7/8. Is that what you said? Or were we both wrong? we were both wrong on a Monday morning. So 8 times 6 is 48. 8 times 7 is 56. It's 9 times 6 is 54 that I always screw up. So 8 times 6 is 48. There's your holes. And 48 is 7. 55 minus 48 is 7. So it would be 6 7/8. We both made a mistake. Okay. Flipping the page. Unless there's other questions. Going once, twice. Okay, we're simplifying fractions. That's a fifth. That's a fourth. That's 1. That is, divide them by 2 is 6. 6 divided both by 4. 3/8. And that's going to be a third. Again, as I've already demonstrated this morning, if you and I have a different answer, it might not be me. It might not be you. So certainly call me on it if I got a different number. We both may have made a mistake. Convert the mix to improper and simplify. This is going to be 18 over 4, which we can reduce to 9/2. This is going to be 51 tenths, which cannot be simplified. I don't think. I mean, 51 is divisible by 3? No, 52 is divisible by 4. 51 is divisible by 3. 3/17 is 51. Okay, so that one's done. 24, 25, 26, 27, 28 twelfths, which we can reduce down to 7/3. Love that. And then 6 1/3 is going to be 19/3, and 19's prime, so that's not reducible. Okay, flipping the page. Convert the improper fractions to mixed and simplify. So this is going to be 7 1/3. This is going to be 4 2/3, which would be, because it would be 4 4/6, which would reduce to 4, and I'll just show the work. 4 4/6, because 6 times 4 is 24, 25 to 6, 27, 28. The denominator is the same. And then 4/6 reduces to 2/3. 43/3. 42. Yeah, it's 14 1/3. 15 tenths is going to be 1 1/2. I is going to be 1 7/8. And K, which would be the second letter H, if you didn't fix it, is going to be 12 3/10. Are there any comments, questions, concerns on any of those? Yes. Which one? E? Okay. So how I did E, just in my head real quick there, is I reckoned, so I was going through my 49s. The easy one to remember is that 39 is divisible by 3. 39 divisible by 3 is 13. For whatever reason, that's the one that sticks in my brain. And then if you go 3 more from 39, it takes you to 42. So if 3 times 13 is 39, and we want to, and 3 more takes us to 42, that means 3 14s is 42. So then this is what's going to become the whole, and then 43 minus 42 is 1. That's how I did it. You can always pull out the multiplication. Again, if the multiplication, the math facts are sticking for whatever reason, you're welcome to, you're not allowed to use your calculators, but you're welcome to use your multiplication tables. I would have hopped to the 3 line, and I would have cruised over to 42. The next one's 45. And then, okay, so it's got to be 42. That's 14 and 1/3. There are mental ways to do it, but you've always got, if that's taking too long, you've always got your multiplication tables to fall back on. I did not assign this Did anyone do it and want to discuss the answer? Did you figure it out? What is it? What is the difference between a 16-ounce brick and a carpenter?
One weighs a pound and the other pounds away.
One weighs.
Was that? It starts at the top.
I know.
Yeah.
I was putting the whole answer at the bottom. A pound, and the other pounds away.
Yeah, I didn't get the football joke though.
The football joke's really bad.
Yeah,
If you did the football one, it's quite bad. The answer to the football one is, what'd you get? Something about a second string?
Yeah, it was. He wanted to tie the game.
He wanted to tie the game. So if you didn't do them, I didn't assign them. They were entirely optional. Write down the answers to the thing, and if you want to use them later to practice, then at least you got what you should get. There's the play on words there. This is one of the lamest pun pages that I have. I have a few buried within, but this one's the really bad one. Why did the football coach send in a bunch of second string players? It's a play on the word string, obviously, because you use string to tie things. And the phrase in sports is second string. It's like you pulled all your starters off and you put on the bench. Like everyone who, for whatever reason, isn't a go-to starter, who's already sitting on the bench, they come in. So that's called your second string. And typically you also use string to tie things. It is quite lame.
Yeah, that makes more sense.
Especially when you have to explain it. But that's okay. Are there any questions, comments, concerns about anything? What's going on here? Sorry, my wife is texting me furiously. Okay. Okay. Let's go. Flip the page. If there's nothing to question, let us jump to comparing numbers. So this is going to start relatively easily, pretty straightforward, and then we're going to launch it into decimals and fractions, and we're talking about size of numbers, and it's really easy for these things to get stuck in your head. And so we want to make sure that we have methods for analyzing the sizes of numbers and figuring out which one's bigger, which one's smaller, all that kind of thing, and then ordering them. So if I'm going to order these things from least or smallest to greatest, biggest, so I'm starting on the left with the smallest numbers and I'm going to the largest on the right, what tools do we have at our disposal to do this? What should you immediately reach for? Mila. A number line. Yeah. This is the tool we use for this thing. And so we talked about building number lines already when we were reviewing, just mental addition and subtraction. You want to, when you're building a number line, just to review, if we're talking about number lines, we care about spacing. We care about the left is the negative or the smallest. Right is positive or the biggest, depending on how you're picturing that. What else did we discuss? I thought there was a third thing. The left to rightness of it all, the spacing of it all. Oh, and you want a place value. That was the other piece. We want to make sure that you've got an anchor, a place value to start. You want to make sure you have an anchor for your number line. So, these are integers. There's nothing ridiculous or crazy about these values. It's 5, -1, 2, -8, and 0. Looking at those 5 numbers, let's pick one of those 5 to act as our anchor. Which one makes the most sense? Bevney?
-1 makes sense to me, so I kind of...
-1 makes sense to you. I don't know. Why'd you put -1 there? There are 3 better values. Tenveen. -8. If you're going to toss -8 on the number line, you're going to put it where? Yeah, it's obviously the most negative. So you could use that as your far left. Guntas, did you have a different one? 5. Okay, the high one on the other end. Or you could pick a middle one. If you're picking a middle one, I still wouldn't pick -1. If you're picking a middle one, I would have picked, Amrush?
0.
0. Okay, so, but we've already placed -8 and 5. Like, this is the smallest one. Like, you can look at that and say, okay, it's the most negative, it's going over there. This is the most positive, it's going to end up over there. And we can slot in, cross them off as you go. We can slot in the other ones as they sit there. So, if we care about spacing, we can kind of parse this out a little bit here. If I've got -8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5's already on there. My spacing's, I mean, it's not perfect, but it's not bad. I just counted off between -8 and 5, and now we can toss these things in here. -8, -7, -6, 5, 4, 3, 2, and -1, 0, and 2. We want to treat the number line properly. I wouldn't just toss them on there haphazardly. If you're going to use the number line, use it properly. Yes, Guntas, is that a hand? No, okay, cool. Space them out. But that's what that's going to look like. We've done the number line. Get that that's there. Use the number line. I mean, you can also, you can play it through in your head. It doesn't take very long to do. But the number line's a tool to lean on. Negative numbers are the left, lowest, whatever you want to, whatever language you want to use for that. Negative numbers are left and lowest the farther they are away from 0. Yes, they look like they're getting larger. Like you've got -50. It feels like a really big number. But the more negative you are, the smaller that value actually is, or the further that value is away from 0. So that's what that piece is talking about in there. And so in other words, the bigger the negative number, the smaller its value is. So that's part of this. What about fractions and decimals? How are we going to deal with these? Ordering decimals can get interesting. And this is usually where I find students get trapped. How do decimals play out? So like if I have an anchor value here, we'll throw a number line on here. If I call this 0 and this -1 and this 1, just to have a perspective on things, what kinds of decimals, give me an example of a decimal that would sit over here close to 0 between 0 and +1, Mishwa? Ooh, where would 1.2 sit? There it is. So 0.2. Give me a decimal between 0 and 1 that would sit closer to 1. Guntas. 0.8. So from 0, things start to grow, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, towards 1. This is generally not where the issue lies. The issue lies on the other side. If I wanted to place -0.2, where would that go in here? Pevney.
Closer to 0.
It would be closer to the 0. -0.2. Just like 0.2 is close to 0 on the right-hand side, -0.2 would be closer on the left-hand side. It mirrors it. Often I will have students be like, okay, so 0.2 went there, so 0.2 goes way over here. Geronimo and Carson. Carson, you're paying attention, right? Okay. Because I'm seeing the back of your head, not the front of your head. So then what would show up over here? Closer to the -1, Pevney.
0.8. Well,
-0.8. And so things, again, they're growing as you get away from 0. One of the mistakes, believe it or not, one of the mistakes I see all the time with decimal values is how you count up in them. So we're dangerously close to one of the mistakes that I see students make here all the time. If I wrote down some numbers here, if I wrote down 0.7, 0.8, and 0.9, What's the next one that falls along in that pattern? A 1. Anyone want to take a guess at the mistake that I see students make as they're climbing up? Yes, Mishma. They do 0.10 instead of 1. And I see this more often as my career goes on. And I don't know why that is. I don't know whether or not it's the language that students use as they're coming out of as you're coming out of middle school or elementary school. Yeah, I don't know why that is, but I'm seeing it happen more and more. Students will say, "Oh, this is," because they've got 7, 8, 9, and then after 9 comes 10. So now we've got 7, 8, 0.7, 0.8, 0.9, 0.10. But 0.10, if we just take this the other way, 0.10 will be exactly the same as 0.1, which is what we would have started with. So that can't be the same, and we need to recognize that as you're going up, like, it's the fraction here that's taking over, right? These are 8 tenths, 9 tenths. The next one would be 10 tenths, which is 1. 8 tenths, 9 tenths, 10 tenths, which is 1. So this one is the mistake that I see that I everything in my power to help you avoid. Want to be really clear with the decimals, and then now let's talk about the fractions. What are some ways for dealing with fractions? Fractions are going to be the thing that causes a bunch of us some grief too. What are some ways we can deal with placing fractions properly on a number line? Yeah.
Converting them to decimals.
One option is to convert to decimals, which we're going to look at it on the next page. Convert to decimals. Okay. That is absolutely one way to handle this. We're going to review some of those conversions on the next page. What's another way you can deal with decimals? Well, let's say if we're using a number line. How do fractions and number lines relate to each other? If there was my number line. I've got 0 there. I've got 1 there. And I wanted to place a 4th on that number line. Without converting it to a decimal, what could you do? Mishwa, you saw your hand first. Okay. So you're making comparisons to other fractions that you know. You know it goes a quarter, and then 2 quarters would be a half, and then 3 quarters, and then the whole. So you're comparing it to a nice, slightly larger fraction. Okay, and a half's going to be in the middle, because half is a half. And yes, it's going to go between 0 and halfway, but where is it going to go between 0 and halfway? Exactly in the middle there. So that's where our quarter is going to end up, because that's a half. And then to make my point, I'm going to put 3 quarters there. Look at the relationship between the value in the denominator and the spacing between 0 and 1. How many chunks did I break up the interval from 0 to 1 into? There's 1, 2, 3, 4 chunks. And I'm dealing with fourths. So that's literally what the fraction's about. Annabella, wake up. And so this is something I was dealing with. Annabella, wake up. This is something I was dealing with my Science 10s about last week. They were using thermometers, and the thermometer had fractions. They're like trying to figure out what the temperature is. And some of the thermometers had 9 lines, so 10 divisions. So each one of those is going up a tenth. Other thermometers had 5 divisions, or 5 spaces. And so those fractions would be fifths. The fractions are fifths. Yes, the decimal is 0.2, 0.4, 0.6, 0.8, but the fraction is a fifth. So the denominator, it's important to recognize here, the denominator is the number of spaces in an, I'll say interval. We'll say it that way. And so then you can break it up. And I'll show you what I mean down here with the 2/3 versus 4/7. There's another way to deal with fractions. Does anyone have another way to compare the sizes of fractions? Let's say I wanted to do this. 2/3 versus 4/7. The sevenths are awful decimals, and I'm not giving you a calculator, so that's going to be a terrible way to do it. And if all I want to know is, we're not placing these on number lines yet, I just want to know which one's bigger. What's an easy way to do it? Mishma?
You could just draw two boxes and separate one box into 7 sections, and the other box into 3 sections, and you can have a visual description.
Yeah, you got to make sure your boxes are identically the same size. You could do it that way. Yes. What about using some of the skills that we looked at on Friday? What is one skill we could use in reverse that we looked at on Friday to help us deal with fractions like this? Oh boy, we could long divide. I don't want to. There's an easier way to do it. Rather than simplifying fractions, we can go the other way. These fractions are simplified. What if instead of simplifying fractions by dividing out the same thing, we made them bigger? There is language around this that I hope you've seen before. Sahib and Yuvraj, are we good? What if we found a common denominator? Min A, there should be an A there, T-O-R. Common denominator. We have found common denominators before, yes? This is a tool we can use to compare sizes of numbers, and I'll demonstrate all of that down here. Okay, so let's crank out some easy ones. Which number is smaller, -50 or -2? -50. How do you know? Give me some justification for that.
It's farther left on the number.
Because it's bigger and negative. So it's going to be further left, which means this is the smaller number. You betcha. Or if you wanted to toss it on a number line, you could. There's 0. If -2 is there, -50 is going to be way over here. And the further left you are, the smaller you are. How about -13 versus -14? -14. This is, for students, this one is more obvious than this one. Because it'll be like -50 versus -2. The spread there is obvious. Then this one, they're like, oh yeah, 13, 14. It's 13 is the smaller one. But again, it's the exact same thing. -10, -13, -14. So that one is the smaller one. Throw them on a number line, either practically or in your head, to crank that out. -2 versus -1, which one's smaller? Pavni, let someone else yell out next time, please. But you're right. Okay, next one. I got 6/3 versus 4. Guntas. Why is 4 smaller? So which one is smaller? If 6/3 can be simplified to 2, which one's smaller? 2. Very good. For exactly the opposite reason that you gave. Well, for the reasons that you gave, the other answer was correct. Yes. Well done. And good job catching your mistake. Okay, let's do 2 versus 6/4. What can we do with that improper fraction to make this more doable without pulling out a calculator and converting everything to decimals? Well, you knew what you were doing last time too. Pavni.
So basically what I did was I simplified the fraction to 3/2.
Okay, hold on. You said that 6/4 is 3/2 using skills you've learned before and the stuff that we reviewed on Friday. Okay, because top and bottom are both divisible by 2. And then you took 3/2 because it's still.
A mixed
And then you went
fraction,
mixed number.
which would be 1 1/2. And since I know
Yep.
that 1.5 would be 1.5, I basically just went like, okay, then 6.
Well, even without doing that, without even saying 1.5 is 1.5, if the whole number here is 1 and the whole number here is 2, which one of those has to be smaller? The whole number 1. Doesn't matter what the rest of it is. The whole number 1 is going to be your smaller one. So that means when you're giving me on a test or a quiz, you've got to be really clear how you're simplifying things, because I didn't ask you what was bigger between 2 and, or smaller between 2 and 1.5. I said 2 and 6/4. So at the end of the day, I want your answer to come back to one of these two values I gave you to start with. So you would say this whole stack. So my answer, which of these two is smaller? 6/4. Whatever work you do to play and convert, you still need to go back and reference the question that was asked. Okay, 2/3 versus 4/7. This is the truly gnarly one. I'm going to demonstrate two of the things that we talked about. I am not going to convert to decimals on this page. I'll convert on the next page. 2/3 versus 4/7. Let's do, I don't know, which one do you want to do first? Common denominator or number line? I'll do both. I don't care which one we do first. Mila wants the denominator first. Okay, cool. So then here's what you ask yourself. You're looking at 3 and 7. Forget the numerators for a second. To find a common denominator, denom, period. What we want to do is we want to find the least common multiple of 3 and 7. The least common multiple is what is the smallest number 3 and 7 both go into. And then not always, but often. And you know what? We don't even need the least. It just needs to be a common multiple. A really easy way to find the common multiple, Guntas, is to do what? Multiply those two numbers together. It will give you a multiple every time. It might not be the least. It doesn't have to be the least. We just need a common multiple. So what I'm going to do here is I'm going to multiply the 3 by the 7 and the 7 by the 3. And then when we're finding a common denominator, what else do we have to do to make sure the fractions stay the same? Whatever we do to the denominator, we have to do to the, Mishwa, numerator. Just like when you were simplifying and you divided top and bottom by the same thing, like 6/4 down to 3/2. We divided top and bottom by 2. Finding a common multiple, we multiply the top and bottom by the same value. So here I multiplied bottom by 7, so top by 7. Here I multiplied bottom by 3, so top has to be multiplied by 3 as well. So then this one is going to become 14/21 and 12/21. So which one is smaller? 4/7. Because if the denominators are the same, we just look at which numerator is smaller. So because 12 is less than 14 and the denominators are the same, these 4/7 must be the right one. That's one way to do this. Here's the other way, for those of you who want to throw things on a number line. If you're like, I hate math, I want to go into the trades, this is the one part of math you absolutely have to do. So let's take a look at these. We're going to break up a number line. 2/3 and 4/7 are both proper fractions. All proper fractions fall between what two numbers? Every proper fraction falls between what two numbers? A proper fraction is one where there is no whole number and the numerator is smaller than the denominator. Every proper fraction is between what two values? Well, 1 on the top end. 1 is correct. What's the bottom one? 0. Every proper fraction. I mean, look at what we did up here. It's the same thing we were counting through. We said, okay, 0.8 is 8/10, 0.9 is 9/10, 1 is 10/10. Every proper fraction here is going to be less than 1, 8/10, 9/10, and it's going to be bigger than 0. So let's place 2/3 and 4/7 on the number line. Keeping in mind what I said before, the denominator is the number of spaces in the interval. So if I'm going to break this thing up, I'm going to do it twice, once above and once below. I'm going to break up the gap between 0 and 1 into thirds. So I need 3 roughly evenly sized gaps between 0 and 1. So it doesn't necessarily have to be perfect, but that's what the bottom one would look like. I've got 1 gap, 2 gap, 3 gaps. And so I've broken this thing up, the bottom half, into thirds. 2/3 is which line? What's your first, Mishwa? Second one, yeah. So that would be, because this is the first third, second third, third third. Okay, now let's do the same thing up top, but into sevenths. Sevenths is going to be trickier, because now I need 7 equally sized spaces between 0 and 1. Oh boy. So then each one of those is going to be smaller. I'm going to have 1, 2, 3, 4, 5, 6. So I got 1 gap, 2 gaps, 3 gaps, 4 gaps, 5 gaps, 6 gaps, 7 gaps. So this is 1/7, 2/7, 3/7, 4/7, 5/7, 6/7. 4/7 is just lower than 2/3. If you prefer visualizing this, the number line is the way to go. For those of you who are going to go off into trades and are going to write fractions of things, that is something you need to be good at. If you don't like pictures, common denominator, because I'm not giving you a calculator and nobody wants to do long division. Comments, questions, concerns? Okay, flip the page. I want you to, okay, we're going to pause here and I want to give you some practice. We're not going to do all of these, unless I do. I want you to do all of these? No, I do not want you to do all of these. I want you to start here with odds. I want you to do both sides. So there's 10 questions. It shouldn't take us very long, but I'm going to walk around and see where we're at. The other piece to this is, whenever you see work that I give that looks like this up top, there's a real good chance that if you flip far enough, you're going to get the answers. So before you flip back and look at the answers, I want you to do 1 to 19. But I want you to do 1 to 19 checking your answers after you've done the things. But I'll come around and help you and see where we're at. On your markets, a go. Comparing the sizes of these. Surprise! Terrible long division. Sorry, video. Don't be away next time. Okay, so the easier way to do this. At some point in the past, you would have learned, hopefully memorized, a bunch of the conversions between fractions and decimals. What are the nice conversions between fractions and decimals? Pavnit, give me one.
1/2 equals 0.5.
A half is 0.5. At some point in the past, that is something that all y'all should have memorized. I mean, it's especially when you're dealing with currency, North American currency. Just 50 cents is half of a dollar. There's my 50 cents. Other currencies, it gets slightly more complicated than that, but at the end of the day, yeah, that's a fraction you should all have memorized. What are some other fractions that you've got locked in? Guntas. Sorry, what? Okay, one more time? Louder. 3 and 1 over 5? Okay, let's make this easier. Why don't you just give me the 4 over 5? Why did you want to toss a whole number out front? Sure, let's talk about fifths. 1/5, 2/5, 3/5, 4/5. You said 4/5 is what? Is it? 0.4. The 4 is in the... What's the place value here? Yeah, you do. We named them. This is the ones. This is the tenths. So 0.4 is not 4/5. It's 4/10, because that's the tenths spot. The name is important. So 4/5 is not 0.4. Let's take a look at what it could actually be. 4/5. One way to deal with the fifths is to make them tenths. 4/5 is how many tenths? Multiply by 2. Multiply by 2, because 5 times 2 is 10. It's going to be 8 tenths. So 4/5 is going to be 0.8. So 3/5 is going to be... We multiply top and bottom by 2 to get us to the tenths. 4 times 2 is 8. 4/5 is 0.8. 3/5. Yuvraj and Mading, stop talking. You can do it, Guntas. I believe in you. Yes, it's going to become 6/10, which is... We don't want to go back to the fraction. I want a decimal value. 3/5 is 6/10, which is 6/10, 0.6. But again, my question to start all this was, Geronimo, I know you're tired. Wake up. You were up late. Geronimo. And we'll let him sleep. You can watch the video. My question to start all this, Guntas, was what are some of the easy fraction to decimal conversions that you've memorized? You picked a hard number that you hadn't memorized. My question, what are some easy ones you've memorized? Maybe we haven't done fifths. Okay, fine. Let's do quarters. Quarters is related to the money, especially if you grew up in Canada. 1/4 is how many cents? 25 cents. So 0.25. 3/4 is then 3 times this. 3/4 is how many cents? 75 cents. So 0.75. What are some other easy ones we've memorized? We've got the halves. We've got quarters. All y'all should remember the thirds. Thirds are just because they're a little odd. What does the third look like? We really not memorized these? Elementary school, middle school? Oh, you've never done them? This is tragic. Really? No.
I wanted to learn them better.
Okay, so can I comfortably say you guys have halves and quarters down just because of money?
Yeah.
Can we say that? Okay, cool. So let me give you some other easy ones. Guntas got us started here with the fifths. If you've done none of these, let's go back to the fifths. 4/5, the fifths can always relate to the tenths. Multiply top and bottom by 2. 4/5 was 0.8. 3/5 was 0.6. So 2/5, Guntas is probably going to be 4/10, which is 0. So then 1/5 is going to be, again, multiply top and bottom by 2 to get us the tenths. 2/10 or 0.2. The tenths fractions are easy too, just because they are directly connected to the name of the decimal place. 1/10 is 0.1, because there's a 1 in the tenths place. 0.2, 0.3, 0.4, 0.5. 2/10, 3/10, 4/10, 5/10, they're all related. The fifths you can generate by turning them into tenths. 1/5 multiply top and bottom by 2 to get 0.2. So I'm hoping fifths and tenths aren't too bad now either, because tenths are related to the names of the decimals and fifths can be derived. Are we cool with that? Sahib, I want to see the front of your head, not the back of your head. The only other one that really shows up as being useful are the thirds, and then by extension, the ninths. Have we really not seen these before? Okay, cool. I'll demonstrate one of them, long division, to show you kind of the trick. I'm going to do the ninth. So remember, the 1 goes on the inside, the 9 goes on the outside. 9 just go into 1? No. So you add the decimal and the decimal, add a 0. 9 goes into 10? 1. So 1 times 9 is 9. 10 minus 9 is 1. Add a 0, bring it down. How many times does 9 go into 10? 1 times 9 is 9. 10 minus 9 is 1. Add a 0, bring it down. Oh, look. 1. 9, 1, 0, 0. 1. Are we getting the vibe?
Meaning that's not.
What is 1/9? 0.1 repeating. Anyone want to take a stab at what 2/9 is? 2/9 is just 0.2 repeating. 3/9 is 0.3 repeating. And Guntas, if I reduce 3/9, what will it reduce to? 1/3. So my thirds are 0.3 repeating. So then 4/9 is going to be 0.4 repeating. 5/9 is 0.5 repeating. 6/9 is going to be 0.6 repeating. But look, if I reduce 6/9, what is it going to reduce to? 2/3. Okay? Your life can be made so much easier with some of these little relationships. Remember that a quarter is 0.25, a fifth is 0.2, a tenth is 0.1. Having those locked in My dang, what are you drawing on? What's that in your left hand there? Eraser. Don't draw on the eraser. Use the eraser. You're supposed to be writing down the notes that I'm giving you. Not drawing on your eraser with Yuvraj's pencil. Okay. Really, we have not memorized these things. Good to know. Okay. So then, what I want you to try and lock in is this column here. Your life will be made so much easier by memorizing those 6 things. Long division, then, for those of you who haven't, long division is definitely an option. Okay. Flip the page. Let's see how far we can get. Yeah, we'll finish this off. Just this one. Converting mixed fractions to decimal numbers. This will be a good practice for locking in some of those things. We want to convert mixed fractions to improper fractions. Well, one method is to convert mixed fractions to an improper fraction and long divide. Again, this is a terrible option, but it works. One way to convert is to do the division. It's awful, but it's an option. If I were to do that for this first question, 1 and 1/9 would be what? Be 10/9. 9 times 1 is 9, plus 1 is 10. If I'm going to set up division here, what number is going to go where?
Goes inside, 9 goes on the outside.
10 goes inside, 9 goes on the outside. So 9 goes into 10 once. 1 times 9 is 9. 10 minus 9 is 1. We're done. There's no decimal there, so let's add the decimal, add the 0, bring it down, and you're going to get the idea that we're going to keep going here. When you place a decimal, you place a decimal. 9 goes into 10 once. So what do you think the decimal is going to be for 1 and 1/9 as we long divide here? Mila. 1.1 repeating. Long division will work. Or you can lock in some of those things I told you to lock in. If you recall, 1/5 Guntas is what as a decimal? 0.1 is 1/10. I don't want 1/10, I want 1/5. 0.2, because I'd multiply top and bottom here by 2. Again, I want you to play with these and so you can lock them in. 1/5 is 0.2. The other method is to say, okay, well, the whole number just stays, and it's the fraction that becomes the decimal after. So 2n 1/5, the whole number is going to stay, and because 1/5 is 0.2, 2n 1/5 is just going to be 2.2. And again, if you've got some of those things locked in, these will be easy. This is what I want you to get to. Otherwise, you're long dividing. So then 3n 1/9 is going to be what? The whole number stays, and the 1/9 turns into what decimal? The ninths are easy.
3.1 repeating.
It's the numerator that repeats itself. 3.1 repeating. There is so much wrong with the next question. Here is what is so much wrong with the next question. You've got not just a mixed fraction here, you've got a mixed fraction with an improper fraction. There's just so much bad going on here. What do I do with this? Four and 5 twos.
Don't you make like the whole number bigger and then like something with the numerator? I forgot what to do.
Okay, well, let's just fix this first of all. Let's let the 4 remain. What is 5 over 2? That's an improper fraction itself, Guntas. What is it? 2.5. So this is going to be 4 plus 2.5. So it's going to be 6.5. Which is what as a decimal? Y'all should know that the halves are
0.5.
0.5. So this is going to be 6.5. Again, locking some of these in. 1/5, 1/9, halves. Something you absolutely need to do. Okay, I know there's only 5 minutes left. I'm going to give you one last thing to work on. If you don't get it done, this one thing is your homework. I want you to put these numbers, try and put these numbers in order. We'll start class tomorrow by discussing how you did that. I want you to try using everything that we've looked at now. Common denominators. Decimals you can look at. You can do some conversions to decimals. Or long division. And if it makes your life easier, start with the number line and then go back to number 1. That is the one task you have, and I will tell you when to pack up, yet not yet. Put those 6 numbers in order for me on your market set go. That's the last thing I'm going to ask you to do today. You have no other homework on your market set giver.